Hello everyone. So we are starting a chapter Unix files. In Unix there are three kind of files. One is regular files, directory file and device file. In device file we have three types: FIFO file, character device file and block device file. So coming to a regular file must be a text or binary file. It is either a text or a binary file. Both the files are executable provided execution rights are set. If the execution rights are given, then both the files, text file and binary file, both are executable. They can be read or written by users with the appropriate permission. If a user has an appropriate permission, he can read or write those files. To remove regular files, we use rm command followed by the file name, rm followed by the file name. Then we have directory file, folder that contains other files and subdirectories. Directory file contains both the subdirectory and other files. Provided a means to organize a file in a hierarchical manner. It means that directory file can be organized in tree-like structure. To create a directory file, we use mkdir, and to remove we use rmdir command. Then we have a block device file. Physical device which transmit a data block at a time is called a block device file. For example of block device file is hard disk drive, floppy disk drive. Character device file, physical device which transmits data in a character based manner. Example for this is printers, modems and consoles. So to create a block or character device file, we use a command called mknode. mknode /dev /cdsk c1155. But here /dev /cdsk is a name of the device. C is a character device, B is a block device. 115 is a major device number or 5 is a minor device number. So what is major device number? It is an index to kernel's file table that contains the address of all device drivers. It contains address of all device drivers. Okay. Then minor device number indicates the type of physical file and IO buffering scheme used for data transfer. To transfer a data, which type of physical file and IO buffering scheme is used, it is known by minor device number. So then coming to FIFO file. FIFO file is a special kind of file, device. It is a device file which provides a temporary buffer for two or more processes to communicate by writing data to and reading data from the buffer. If two processes wants to communicate, one writes the data to the FIFO file, then other file reads data from that FIFO file. Maximum size of the buffer is known by pipe buff. The storage of the FIFO file is temporary. The file exists as long as there is one process is in direct connection to the FIFO for data access. If either one process in direct connection with the FIFO, then we can't terminate the file. Okay. To create a FIFO file, we use mkFIFO or mkFIFO. Okay, same. So we use mkFIFO, user program, FIFO file. A FIFO file can be removed like any other regular file. So then we have a symbolic link file. A symbolic link file contains path name which references another file in either the local or remote file system. It references another file in local or remote file system. It has a dangling link. Okay. To create, we use a -s option. Okay. -s option, target and symbolic link, both are used. It is a program which helps us to know how to create a file and how to create a symbol link. Here we have created a file, then we have created a symbolic link using -s command. Then we tried to access a symbolic link. The output will be hello world, same as the file we have created. Then we have removed the original file using rm command, rm original.txt. Then we attempted to access the symbolic link. So output is like no such file or directory. So once the original file is removed, we cannot access the symbolic link file. So then coming to Unix and POSIX file system. POSIX means Portable Operating System Interface. Portable Operating System Interface and Unix both have a tree-like hierarchical file system. Okay, the slash denotes the root, dot denotes the current directory, double dot denotes the parent directory. Then name max, maximum number of character in a file name, and path max is the maximum number of character in a path name. Then common Unix files. Those are common files. These are common Unix files. Slash etc means stores the system administrative files and programs. Slash etc slash password stores all user programs, all user information. Okay, slash etc slash password passwd stores all user information. Slash etc slash shadow stores user passwords. Shadow means password. Okay. Slash etc slash group stores all group information. Slash bin directory stores all system programs. Then slash dev stores all character and block device files. Slash user slash include stores standard header files. Slash user slash lib stores standard files. TMP file stores all temporary files created by the programs. So then Unix and POSIX file attributes, file type of file, access permission, the file access permission for owner, group and others. Hard link count, number of hard links of the file. UID, the file owner user ID. GID, the file group ID. File size, the file size in bytes. Last access time, the time the file was last accessed. Last modified time, the time the file was last modified. Last change time, the time file access permission, UID, GID or hard link count was last changed. Then we have a inode number. Inode number means the index number or metadata, the system inode number of the file. So lsl command to access the inode information. LSI command it is. LSI command to access the inode information. Stat file name command to provide a complete file type along with the inode number. Stat file name. This command shows the complete file type along with the inode number. File system ID is the where the file is stored. The system ID is where the file is stored. So attributes of file that remain unchanged. We cannot change these attributes by giving the command. There are 4 attributes like that. One is file type, one is inode, another is inode number, then system ID and major and minor device numbers. Other attributes can be changed using Unix commands and system calls. So there are many Unix command. According to that Unix command, we have system call and attributes changed. Okay. First is chmod. Chmod changes access permission last change time. Access permission means read, write and execute. This permission can be changed by chmod. Chown changes the last UID, last change time. Chgroup changes the group last change time. Touch or utime changes the last access time, modification time. ln increases the hard link count. rm decreases the hard link count. If the hard link count is 0, the file will be removed from the file system. vi-emac changes file size, last access time, last modification time. So inodes in Unix system. So now study what is inodes. Unix system file has an inode table which keeps track of all the files. So there are one inode table in Unix system file which keeps track of all the files. Each entry in inode table is an inode record. Each entry contains an inode record. Inode record contains all attributes of the file including inode number and physical address of the file. Information of file is accessed using its inode number. If you want to access some information of the file, we just use the inode number. Inode number is unique within the file system. Each file has a different inode number. It is very unique. A file record is identified by file system ID and inode number. A file record